Hello mathematicians. Today we see one nice problem asked in CSIR June 2014. It is a part C problem and it is a very much a simple topology problem. Only tricky part is they are talking about relatively compactness. So if you have I mean this notion of relatively compact, it's not very common in the at least in the master level syllabus. So once if you know the definition of relatively compact, then this problem is almost immediate. Okay, let's see the problem. So x is given to be set of all xy belongs to R2 such that x square plus y square less than 5. Note that this is strictly less than 5, there is no equality. That means that x is the, so here I have drawn many circles. So if you look at the outside circle, it passes through root 5. Okay, so basically this length is root 5. Therefore, the outermost circle is a circle of radius root 5, and here they are saying that x is the interior of x square less than 5. Okay, equal to 5 means it is circle, greater than 5 means it is outside the circle, less than 5 means it is inside the circle. Okay, so now we know what is the set x. The set x is precisely all these points lying inside this outside circle, which is circle of radius root 5. Okay, good. Note that the points on the circle are not included in the set x because it is strictly less than. Okay, so okay, now we know what is x. Let's look at k. So k is set of all xy belongs to R2 such that 1 less than or equal to x square plus y square less than or equal to 2. So these so this is we saw it is the interior of circle. Such regions are called annulus regions. Okay. So what is this region? 1, 2. So basically you have to draw a circle of radius 1 and circle of radius root 2, and then you see here this is the circle of radius 1 and this is the circle of radius root 2 and any point lying between them. Okay, that is the region that points are given by this region. Why? Because 1 less than or equal to x square plus y square means that x square plus y square greater than or equal to 1. That means that we are looking at points lying outside the unit circle. Again, so basically that will give us all these points. Anything lies outside this circle of radius 1. And then again we are looking at this circle x square plus y square less than or equal to 2. So less than or equal to 2 means points lying inside the circle of radius root 2. So now again we are looking at the points lying inside this circle of radius root 2, and we want this both the inequalities should be true. That means that you are looking at the points, they are lying outside this circle and inside this circle. Okay, so what will you get? You will get basically this white color region. This region is what you will get by these inequalities. Similarly, if you look at the 3 less than or equal to x square plus y square less than or equal to 4, you get this white color region. Okay, so we get this white color region, and so there is a less than or equal to in both the places. Therefore, this white color region with this boundaries also included this two circles. Okay, also included in K. Okay, so basically this points belongs to this region is K, this region is K. Note that K consists of set of all x comma y satisfying this condition or this condition. It means that so if point satisfies this condition also will be here. If it satisfies this condition also will be here. Basically R means union. So you have to take the points satisfying this condition, union points satisfying this condition. Okay. Therefore we get our set K to be union of these two white color regions along with its boundary. So in K, this circle is belongs to K. Similarly, this circle is also belongs to K. Okay. Similarly, again, if you notice, see, this circle is also belongs to K, and this circle is also belongs to K, because there is less than or equal to. So x square plus y square equal to 1 is an element of such elements are belongs to K. Again, x square plus y square equal to 2 also belongs to K because of this equality. So there are 4 equalities also here. So we get this circle, sorry, this circle and this circle, this circle, all these 4 circles are belongs to K. Okay. Okay, good. Okay, so basically K is white color region. K is a white color region with its boundary. And what is X? X is all the points lying strictly inside the circle of radius root 5. Now they are asking about X minus K on all the options. So what is X minus K? So X is all the points lying inside this outermost circle. Note that the points on this circle are not in the set X. Okay. So basically all the points lying inside this outermost circle is the set X. Okay. Now I am removing this our K. Once I remove K, what we left with is precisely the yellow color region. Okay. But one tricky thing is K, as I said, K contains all these circles, right? Therefore, when you remove the K, so the boundary of this shaded yellow color region will be gone. Okay. So even though these yellow color shaded regions are drawn with boundaries, that boundaries are not part of the set X minus K. Okay, because the boundaries are belongs to K. So anyway, the outermost boundary is not part of our X, because X is given to be strictly less than 5. So we know this boundary is not belongs to X minus K, because it is not even belongs to X. Then this circle and this circle, this circle, this circle, all these 4 circles are belongs to K. Therefore, when you remove them, when you remove K, all those circle will also go away with K. So we left with only these 3 region and without the boundary. So basically this is a interior of unit disk, and this is a annulus but open annulus. Both the boundaries are removed. Again this is a open annulus. Okay. Okay, good. Now we go to the options. First option says that x minus k has 3 connected components. You see, this is a first connected component, this is second connected component, this is third connected component. Okay, so first option is correct. X minus k has 3 connected components. Okay, next all these options are about relatively compactness. Okay. uh, okay, so in the x minus k, this is one connected component, this is another connected component, this is another connected component. Okay, now what is relatively compact? Relatively compact means, if you notice, this is a open set, because in x minus k this is a open set because it is interior of a unit disk. Okay, therefore it is an open set. And similarly this annulus is also a open set, because given any point you can draw a small neighborhood around it. Okay, and since the boundary points are not included in x minus k, you take all the points inside only, so you can draw such a small neighborhood. Here also you can draw neighborhood. So basically this is a open connected subset of x minus k. This is a open connected subset of x minus k. Again this is also open connected set of x minus k. So this is a open unit disk. Okay, this yellow color shaded region. Therefore, it is we know that open unit disk is not compact because in Rn a subset is compact if only if it is closed and bounded. In Rn, space is not compact. Okay, so here also in X is in X also this space is not compact. Now again this is also open set we just saw, therefore it is not compact. The yellow color shaded region I'm saying, because it has no boundary. Again this is also open set, therefore again that is also not compact. Okay, now the question is x minus k, whether the connected components of x minus k are relatively compact in X. Okay, so a subset is said to be relatively compact in X if you have to take the closure of that set in X. Okay, and if that closure is compact, then we say this connected component is relatively compact in X. Okay, so now we look at this first, this connected component, and if you take the closure of this connected component in X. Okay, so again recall that X is the interior of the outermost circle. So when you look at the boundary of this first connected component, you will get the boundary. This circle will also be included. Okay, so once the unit circle also included, this is compact. Okay, therefore this connected component is compact. Similarly, this region doesn't contain these two circles. Okay, but when you take the closure in X, you will get these two circle will also included along with this yellow color region, so you get this region also compact. Okay, so this closure is compact, therefore this is a relatively compact in X. Again this region also, this yellow color shaded region also relatively compact in X, because when you take the closure, these two circles are getting included, so we get this closed and boundedness. Okay, therefore it is compact. Now we come to the third connected component. So this is relatively compact, this is relatively compact. When we come to this third, this yellow color shaded region closed, that this connected component, when you take the closure in X, you will get only this interior line. Okay, you won't get this exterior, sorry, you won't get this outside circle, because that circle is not even in X. We are looking at the uh, closure in X, but X itself doesn't contain this outside circle, because X is given to be strictly less than. Okay, the condition given is strictly less than. Therefore, if you look at the closure of this yellow color shaded region, you will get only this circle and you won't get this outside circle. Basically, it will be looks like close 0, 1, that kind of situation. So, which is not compact. Okay, so this closure is not compact. Therefore, this third connected component is not relatively compact in X, but this is relatively compact, this is relatively compact we saw. Therefore X minus K has two relatively compact connected components in X. That is the final answer. Okay, so X minus K has no relatively compact connected components is wrong, because this is relatively compact, this is relatively compact. Again, all connected components of S minus K are relatively compact is also false, because this outside connected component is not relatively compact. Okay, so little bit tricky concept. I hope you understand. Please let me know if you have some doubts. Okay, okay guys, take care. Good night.